Okay, now we're ready. Problems 14 through 18 of this test number 3, part 2 review. So far we've been doing indefinite integrals where the answer is always some expression, has some, in our case, has x's in it. So for instance, here's the first definite integral problem. We still have the integral sign, but the difference is now, you notice, at both the bottom and the top there's a number. So the integral of 3 dx, 3 with respect to x, and now we have a low and a high number. Let's compare that to if we were just trying to solve the integral of 3 dx. Since it's a constant, we would write 3x plus c and we're done. So this is an indefinite integral problem. A definite integral, you still do the integration. So I'm going to take the integral of 3 dx, which is just 3x, but instead of writing the constant, what we do is we put this vertical line here, and at the bottom of the vertical line we put our bottom number here, and at the top we put that number there. And now what this represents is basically, here's what we're going to do. This says, take your answer, your expression, put in 1 for all the x's, and then you subtract, you put in -2 for all the x's. So it's almost like the top subtract the bottom. Where the top is you plug that number in for x, and whatever that is, you subtract whatever you get when you plug in -2 for x. So just to make it clear, I'm going to substitute 1 in for x, then I subtract, now I'm going to plug in -2 for x, so this is 3 times -2 is -6, but subtracting -6 is +6. When you solve a definite integral problem, your answer is going to be a number. All right, hopefully that wasn't too confusing. Let's do a few more of these, and as we do them, if you're a little unsure, hopefully it'll become clear. 15. The integral from 1 to 4 of 5 minus 2x dx. So the first step is to take the integral, to try and solve the integral, and then we worry about all the numbers after we figure out the integral. So this is like 2 terms, so we integrate them separately. The 5 becomes 5x, then minus the 2, we use a power rule here, right? Add 1, you divide by the new, and I'm going to go from 1 to 4. Let me just write this to make it very clear. So that's what I have. I took the integral, it's 5x minus x squared, but I'm going to evaluate it from 1 to 4. So once again, you put the top number in. Every place you have an x, I'm going to substitute a 4 in for it. So 5 times 4 minus 4 squared. And I encourage you, especially when you're subtracting, the lower one, put the whole thing in parentheses, or you're probably going to have some sign errors, and then you're going to get the correct answer. So minus, now I plug in 1. Every place I have an x, I put in a 1. 5 times 1 minus 1 squared. And now it just becomes a math problem. Do your math correctly. 20 minus 16, 5 minus 1, 4 minus 4. Looks like that whole thing equals 0, which I think is correct. Sort of interesting. All right, so really not too hard. Mainly it's do the integral and then plug in the numbers. So hopefully by now you're pretty good at the integrals, and then just be careful with the numbers. So the integral from 1 to 4. Now this original problem is square root of x. I'm going to save a step and go ahead and switch it to x to the 1/2. Do I know how to take the integral of this? Yeah, this is a power rule problem, right? 2 goes out front. Add 1 to your exponent, divide by the new exponent, and all of that, we're going to evaluate it from 1 to 4. Complex fraction, multiply the top by the reciprocal. This looks like 4/3 x to the 3/2. Now here's a case, since I have to put numbers in there, I'm going to actually switch this back to a radical, because personally I can usually have an easier time figuring out numbers with radicals rather than rational exponents. So this is really 4/3. X to the 3/2 means square root, and the square root is x cubed. And just to make the math easier, sometimes if you have a coefficient out front here, I should put this here. You just move the coefficient outside the parentheses. So now I'll plug in 4 square root of 4 cubed minus square root of 1 cubed. 4 cubed, 4 times 4 times 4. 4 times 4 is 16, times 4 is 64. What's the square root of 64? 8. 1 cubed is 1, square root of 1 is 1. Looks like 8 minus 1. Looks like 7 times 4/3. Of course, a number times a fraction, you multiply the number times the top. And you divide by the bottom. I believe that's the answer. All right, 2 more. Once again, as long as you know how to do the integrals, the number part, it's not too bad, just got to be careful. 17. Integral of -1 to 0 of minus 3x to the 5th minus 3x squared plus 2x plus 5, all integral with respect to dx. Now, as far as the integration goes, pretty straightforward. I got 4 terms, but I think I can use the power rule for all 4 of those. So -3x to the 6th over 6 minus 3x cubed over 3 plus 2x squared over 2 plus 5x, and then you evaluate that whole thing from minus 1 to 0. First of all, 3 and the 3's cancel, 2 and the 2's. This becomes 1/2. Let's just rewrite this to make it a little bit nicer. Negative 1/2 x to the 6th minus x cubed plus x squared plus 5x Okay, evaluate it from negative 1 to 0. So plug in zeros. Now, hopefully, I'm not going to write this up because if you plug in a 0 for every x, what happens? Everything just goes to 0. So basically, I have 0 minus, now I plug in negative 1. So negative 1 to the 6th minus negative 1 to the 3rd plus negative 1 squared plus 5 times negative 1. So basically the negative is here. Negative 1 to the 6 is just positive 1, so this is negative 1/2. Negative 1 to the 3rd is negative 1, but I'm subtracting a negative 1. Negative 1 squared is just 1. 5 times minus 1. 2 minus size minus 3. So we have negative 1/2 minus 3, which that's like 6/2. Negative 7/2, but the negative out here, and if I didn't mess up, we'll see if that's the correct answer, and lo and behold it is. Okay, and the last one. Integral from negative 3 to 0 of 2x plus 6 raised to the 4th power with respect to x. All right. I need to first take the integral, and I really can't do that as it sits. Looks like one that we may have to do a substitution on. Let's let u equal the stuff inside the parentheses. The u dx is 2. So dx is 1/2 du. Now let's substitute. See if we make any progress. 2x plus 6 is u, so u to the 4th. dx is the 1/2, which I'm going to move out front. Alright, that's good because I can take the integral of that. Power rule, u to the 5th over 5. Switch the u back to x. I shouldn't put these here because those are with respect to x. It's 2x plus 6. Oh, I should just, 2 times 5 is 10. So 1/10 times 2x plus 6 raised to the 5th power, and now I can put my numbers in here. 1/10 stays out front. So 2 times 0 plus 6 raised to the 5th power. So that's plugging in 0 for x. I pulled the 1/10 out. I should make it a bracket. Minus, now put in minus 3 for x. 2 times minus 3, all that raised to the 5th power. So if I can fit this in, 2 times 0 is 0, so it's like 6 to the 5th. Minus, this is negative 6, plus 6, looks like 0. The number, I'm going to leave it like that. It's a pretty big number. 6 to the 5th over 10. I guess if you look in your notes, it's the same thing as over 5, or if you actually round it to a decimal. Pretty big number. All right, so those are solving some definite integral problems, and before that we went through the indefinite integrals, so hopefully practice these, it'll become clear and you'll be able to do well on the exam.